Yes, I can. Can you hear me?
Yes, very well. Terrell, Russell from iRODS, to now shifting now a bit to the technology side of things, the specific technology side of things. Please, the floor is yours. Yeah.
I'm going to try and not share my email here. Draw a little box. Can you see green things on your
Yeah,
screen?
we see your slides. Thank you, Terrell.
Excellent, excellent. So I'm aiming for less than 20 minutes. We will see how it goes. I think we'll be okay. Thank you for inviting me. This is very interesting, and I've listened to a couple of these. It's early here. I'm in California at the moment, and I have to get on an airplane, so this will not take too long. So I'm going to talk about iRODS kind of as a technology, and then also a little bit of how I think it fits into this larger conversation, and hopefully won't say too many things that are too controversial. But if I do, you can definitely ask me questions. Let's see if I can make the slides go. Here we go. So the iRODS consortium is an organization kind of inside of the Renaissance Computing Institute, inside the University of North Carolina, Chapel Hill. So this is not a company. This is a project. I work for the university, and it's a piece of software, and it's a protocol, and it's a consortium. So all of these things together. The people who actually give us some money are largely into three groups. So they're people doing science. We've got storage vendors that want to maximize their compatibility with what we do. So they are in the group here. And then I think the third group would be technology integrators, people who are boots on the ground, and kind of do, so we will train them, and then they maybe hold, level 1 support contracts with different institutions. And so these are people all over the world. And there's a lot more people that are using iRODS and that help us, but they don't get their logo here because they don't give me any money. It is open source, and we give it away. So today's talk, I'm going to talk about what iRODS is a little bit, a couple particular use cases around health research, and then a bit about the philosophy of how to do this well, I think. So iRODS itself is open source. It's a C++ application. It's BSD3. It runs on a variety of computers, big computers, little computers. And the idea is that it's data centric, but it's metadata driven. And so I'll talk a little bit more about that. The biggest idea here is that it's a future kind of insurance policy. It'll allow you to insulate your users and your data from changes in your infrastructure over time, because we all know that infrastructure does continue to change. We really are trying to take a 100-year view on different things, how to hold it, how to do it, how to name it well. It is a plug-in architecture, so the goal is that the bones are very strong, and that the pieces that we kind of add to it over time can be swapped out and be composed. We're driven by the idea that people can configure things and not have to write their own code. Of course they can, but my job is to hear the landscape of opportunities and what people are working on, and write things as generically as possible. It's a lot of the same kind of work that GA4GH is doing in a particular vertical. And so most people come to iRODS when they have too much stuff in different places, and they want to make sure that they can get their arms around it and control it. They also want to be able to find things, obviously. And then I think one of the things that sets us apart from many other solutions and platforms is the fact that it's fully programmable. So things can be automated in a very flexible way. The software sits above, or you can think of it as kind of connecting a bunch of different disparate existing infrastructure. It is a protocol, it is an API, and so various clients can talk to it. There's client libraries and all your favorite languages. And so people have written applications custom to what they need to talk to iRODS. We do 4 things well. We abstract the storage layer, so we can talk to object and disk and tape all at the same time in different places, different technologies. We provide a metadata catalog where arbitrary user-defined, admin-defined metadata can be attached to different things in the system. The collections, the data, the people, the storage areas, all these things can be described. And then we have a policy engine where rules can be written that can be applied and take that metadata, take inputs into consideration, and then take action on the data based on what else is happening in the system. And so that's very flexible and powerful. It also, because it's an open protocol, it can federate with other instances of itself. So different organizations can talk to each other in a secure way. Authentication happens at home, but when you're working on somebody else's infrastructure, their policies are in place and their logging is happening and all of that. So that's kind of the bones of it. On top of that, this is what I was talking about, configuration. We have seen people want to do storage tiering. We've seen people want to do automated ingest and indexing and talk about auditing and compliance. And so we have code that can do most of that for people, and it's a matter of configuring it correctly. And these are driven by what we've seen in the community. Here's another picture with the same words. I feel like I've got this screen clipped a little bit here. A couple more pixels. This slide's about how the flexibility in the system can actually afford different places in this timeline to happen at the same time in your data. So as data becomes more mature, you may need different policies in place. So when you've got a private collection versus a shared collection versus a published thing, something that's become a reference collection, you need different policy to protect it, to keep it safe, to have it in different places, to make sure that it's got a DOI. And so, yes. Is there a question? Maybe not.
Nope, it was just noise.
Okay. So next, a few policy-driven use cases. The Sanger Institute in the UK has an extensive omics onboarding and processing platform. It's mostly automated, coming off the sequencers. And so there's rules in place to make sure things are good and ready, comes into the system. When it's time to do some science, queries can be run and data sets can be pushed into the parallel file system. And then when the jobs are finished, they can be attributed back to the inputs, back to the processes, as well as published out to websites and things, because the public institution has a publishing mandate. And so this is all built in iRODS. They've been iRODS users for more than 10, 13, 15 years, something like that. What is time? They replicate things as a matter of policy across different data centers, immediately checksums. They're protected against fire and flood for different reasons. They attribute a ton of metadata to every object and collection in the system. So, what the setting of the blue laser was, what the study ID, all these things mean that this stuff is searchable and findable and becomes inputs into their study data. And again, they also federate. So they've got separation of different projects and different funding areas, but in the namespace. So as the projects either get spun up or need to be spun down, there's a separation in terms of access and control to the data itself. So people who have access to the sequencing data or the population data don't necessarily have access to the genetic data or even to the archive. In Maastricht, in the Netherlands, their university medical center has standardized on iRODS as the object store and has many interfaces into it from different places with different people. So they've got their research side, they've got their actual clinical side, all talking to the warehouse that's powered by iRODS and where it's keeping its data and has access to the different parts. Here's a different picture with some of the same words, but again, they've got different clients talking to things. They've got data in the hospital, data in the university, data at SURF, and all available on different technologies, but through the same namespace. The Berlin Institute of Health, they are doing similar omics work as what Sanger's doing, but they explicitly called out before they started to build this system the FAIR principles, and looked around, and because of the open source nature of what we do and the fact that it is extremely flexible, they and the fact that they had to have a multi-institute collaboration, they picked iRODS as well. And then here's some more words about what they're doing. They do their study design. It's all query driven as well, so they can find the inputs based on queries of the metadata of what's in the system. I just heard a talk about GA4GH in general, and so iRODS has a new community-driven data repository service driver, and this is going to be actually introduced and talked about next week at our user group meeting. I've got a slide here at the end to talk about that. This is coming out of NIEHS, or of the NIH in the US, and should be pretty exciting. It means that all of the information that's in an iRODS system can be made available and visible to the GA4GH community and the ecosystem. And then the last little bit here is about how to do this well. And so what we've really learned is that everybody has opinions, it turns out. Everybody has existing architectures, existing infrastructures, and there's always trade-offs between going fast, going big, making it cheap, and having it last a long time. And it does require something that's flexible if you want for it to be around a long time. One of the ways that we've done that is spent time over the last few years making iRODS visible and available as different protocols to different systems, so that other existing systems don't have to change or learn as much. And so iRODS can now be presented as
Terrell, can you hear us?
As access through public and private keys with SFTP. Now, some of these protocols don't afford visibility into the metadata part of iRODS. These are limited. The iRODS API is richer than some of these protocols, and so they can't necessarily do the administrative things or the metadata things, but it can present as what meet them where the protocol is, as well as like a Kubernetes container storage interface doesn't know about metadata in iRODS either. And then what we're working on right now is to try and make iRODS present as S3, which is new and interesting. We think that there's a ton of tools out there that love talking to S3, and so if we can provide a flexible backend and all the policy that we work on as well, we expect that to be extremely popular in the next few months. We also spun up an imaging working group about 1.5 years ago. And surprisingly, to me anyway, all of these people immediately showed up within a couple months, and were very interested in getting their imaging information coming through or out of Omero, which is another open source ecosystem for image capture and microscopy. And they needed a more flexible, powerful backend. And so we're working on a little sync agent that can talk between these two systems. And then we've already solved the visibility issue with this NFS mount point or export. So this is a very interesting conversation, and we, of course, welcome anybody who finds that to be compelling. The big picture is that the flexibility is really key. If you've got to do things that require discovery, if you need to do logging for compliance, you have to write stuff down, and so we do a really good job of the bookkeeping. And the fact that it's a programmatic environment, and every operation in the whole system can be instrumented to do other things. You can reach out to other systems and gather context. You can report. You can log. This is how you are able to stitch things together. And the statement here at the end is that if you're going to do this, you have to have it be policy driven. It has to be done by policy enforcement. And then you also have to understand that your policy will change, the infrastructure will change. And so if you're not building with that in mind, then you're going to have the same conversation again in 3, 5, 8 years. And that doesn't seem very efficient. If you want to have that 100-year view, we also think that it's important that open source be part of it, if not the primary driver, to protect yourself over time. And then the last slide here is to let you know that if you want to, if this is interesting, we have a 2-day, 4 days, but Tuesday and Friday are physical. You have to be there for training and troubleshooting. But our 2-day conference next Wednesday and Thursday is available. You can sign up if you want to. iRODS.org. And then if you /UGM, you can see all of the past. This is the 15th annual, so we've had a few years of papers and talks that are all publicly available and watchable if that's interesting. And that's it. Thank you.
Thanks a lot, Terrell. Are there questions for Terrell? No, not from the audience. So in which case, thanks again. I'm sure your talk has been, intriguing and inspiring for those in the audience that are, building things and touching storage and setting up system in the clouds. And so thank you very much. If offline questions will pop up, I will route them to you. We're in touch, and I release you to take your airplane, I guess. Thank you very much.
Hoping to be home
for our, stretching the agenda a bit.